ಸೂರ್ಯನ ಅಬ್ಸರ್ವ್ ಮಾಡೋದಕ್ಕೆ ಇರುವಂತ ಪಾಯಿಂಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವುದು? ಟು ಅಬ್ಸರ್ವ್ ದ ಸನ್, that is nothing but L1 point. The satellite will start to rotate along with the gravitational pull of Earth. So Earth attract ಮಾಡ್ತಾ ಇರುತ್ತೆ and sun is also attracting. We have launched Aditya-L1 satellite to make constant observation of the changes that are taking place on the sun. So rest of the thing, L3 is also an imaginary point. Theoretically it is true, but practically till now we have not used L3. Other than USA and Russia, India is the only country to have launched a similar observatory into the space. So transfer orbit is an orbit, so it will be presenting just below your actual orbit. Either it may be Leo, MEO, or it is GEO. ಸೊ ಆಕ್ಚುಯಲ್ ಆರ್ಬಿಟ್ ಗೆ ಪ್ಲೇಸ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ ನಾವು ಹೊಸ ಊರಿಗೆ ಹೋದ್ರೆ ಫಸ್ಟ್ ನೋಡ್ತೀವಲ್ವಾ, ತಿರ್ಗಾಡ್ಕೊಂಡು ಒಂದು ರೌಂಡ್ ಎಲ್ಲಿ ಸೆಟ್ಲ್ ಆಗ್ಬೇಕು ಫಸ್ಟ್ ಅಂತ ಹೇಳಿ. ಸೊ ಆ ತರ ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ನೋಟಿಸ್ ದ ಥಿಂಗ್ಸ್. ಸ್ಯಾಟಲೈಟ್ ಮಾಡಲ್ಲ, ವಿಲ್ ಬಿ ಕಂಟ್ರೋಲಿಂಗ್ ದಟ್ ಅಟ್ ವಾಟ್ ಟೈಮ್, ಸೊ ವಿಚ್ ವಿಲ್ ಬಿ ದ ಪರ್ಫೆಕ್ಟ್ ಪ್ಲೇಸ್ ಟು ಲ್ಯಾಂಡ್. ಸೊ ಇಲ್ಲಿ ಇಳಿದ್ರೆ ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಳಿದ್ರೆ ವಿ ಕ್ಯಾನ್ ಡೂ ಮೋರ್ ರಿಸರ್ಚ್, ಎಲ್ಲಿ ಡಿಸ್ಟ್ರಾಕ್ಷನ್ಸ್ ವಿಲ್ ಬಿ ಲೆಸ್. ಸೊ ಬೈ ನೋಟಿಸಿಂಗ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಟ್ರೈ ಟು ಲ್ಯಾಂಡ್. ಸೊ ಸೀದಾ ಹೋಗಿ ಹೊಪ್ಪ ಅಂತ ಬೆಳಕಾಗಲ್ಲ ಅಲ್ವಾ, ಸೀದಾ ಹೋಗಿ ಬಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಎಲ್ಲ ಪುಡಿಯಾಗಿ ಹೊರಟೋಗುತ್ತೆ. ಈವನ್ ದ ಎನ್ವಿರಾನ್ಮೆಂಟ್ ಮೇ ನಾಟ್ ಸಪೋರ್ಟ್ ಓವರ್ ದೇರ್, ಕೆಳಗಡೆ ಹೋಗಿ ಲ್ಯಾಂಡ್ ಆಗುವಾಗ. ಸೊ ಹಾಗಾಗಿ ಏನ್ ಮಾಡ್ತೀವಿ, ಫಸ್ಟ್ ವಿಲ್ ಪ್ಲೇಸ್, ವಿಲ್ ಜಸ್ಟ್ ಮೇಕ್ ಸಮ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್ ಇನ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆರ್ಬಿಟ್, ದೆನ್ ಅಟ್ ಸೂಟಬಲ್ ಟೈಮ್ ವಿಲ್ ಪ್ಲೇಸ್ ದ ಸ್ಯಾಟಲೈಟ್, ಬಿಕಾಸ್ ವಿಲ್ ಬಿ ಸ್ಪೆಂಡಿಂಗ್ ಅರೌಂಡ್ 500, 300, 400 crores ಪರ್ ಸ್ಯಾಟಲೈಟ್. 400, 500 ಕೋಟಿ ಹಾಕ್ತಿವಿ, 1 ಕೋಟಿ 2 ಕೋಟಿ ಆದ್ರೂ ಸಮ ಓಕೆ ಅನ್ಬೋದು ಅಲ್ವಾ. ಸೊ ಹಾಗಾಗಿ ಮತ್ತೆ ಫಾರ್ ಪ್ಲಾನಿಂಗ್, ಎಕ್ಸಿಕ್ಯೂಷನ್, ಸೊ ಎವ್ರಿಥಿಂಗ್ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಸೋ ಮಚ್ ಆಫ್ ಟೈಮ್. ಸೊ ರೀಸೆಂಟ್ ಆಗಿ ನೀವು ನೋಡಿದ್ರೆ PSLV C61 ಇಟ್ ಹ್ಯಾಸ್ ಗಾಟ್ ಫೇಲ್ಯೂರ್. ಟುಡೇ ಐ ವಿಲ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ದಟ್ ಅಲ್ವಾ. ಸೊ ಏನಾಯ್ತು, ನಿಮಗೆ ಥರ್ಡ್ ಸ್ಟೇಜ್ ಅಲ್ಲಿ ಇಟ್ ಹ್ಯಾಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಡಿಸ್ಕನೆಕ್ಟೆಡ್ ಅಂಡ್ ಇಟ್ ಸ್ಟಾರ್ಟೆಡ್ ಕಮ್ಯುನಿಕೇಟಿಂಗ್ ಇನ್ ರ್ಯಾಂಡಮ್ ವೇ. ಸೊ ಕರೆಕ್ಟ್ ಆಗಿ ಸ್ಪೇಸ್ ಸ್ಟೇಷನ್ ಜೊತೆಗೆ ಇಟ್ ಹಸ್ ನಾಟ್ ಸ್ಟಾರ್ಟೆಡ್ ಕಮ್ಯುನಿಕೇಟಿಂಗ್ ಅಂಡ್ ಇಟ್ ಸ್ಟಾರ್ಟೆಡ್ ಡಿವಿಯೇಟಿಂಗ್ ಫ್ರಮ್ ದ ಆಕ್ಚುಯಲ್ ಪಾತ್ ಅಲ್ವಾ. ಸೊ ಹಾಗಾಗಿ ಸೊ to failure means it is almost like wasting of 400, 500 crores. So then we have launched GSLV. ಮೊನ್ನೆ ಮತ್ತೆ GSLV F16 something ಅದನ್ನ ಒಂದು ಸ್ಯಾಟಲೈಟ್ ನ ಲಾಂಚ್ ಮಾಡಿದೀವಿ ಅಲ್ವಾ. ಸೊ ಹಾಗಾಗಿ ಲಾಂಚ್ ಮಾಡಿದಾಗ ಟು ವಿಚ್ ಆರ್ಬಿಟ್ ವಿ ಆರ್ ಲಾಂಚಿಂಗ್, ರೀಸೆಂಟ್ ಆಗಿ ಲಾಂಚ್ ಆಗುತ್ತಲ್ವಾ. ಸೊ ಟು ವಿಚ್ ಆರ್ಬಿಟ್ ವಿ ಆರ್ ಲಾಂಚಿಂಗ್, ಸೊ ವಾಟ್ ಈಸ್ ದ ಪರ್ಪಸ್ ಆಫ್ ದ ಸ್ಯಾಟಲೈಟ್ ಅಂಡ್ ವಾಟ್ ಆರ್ ದ ಅಬ್ಸರ್ವೇಷನ್ಸ್ ವಿ ಕ್ಯಾನ್ ಮೇಕ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಸ್ಯಾಟಲೈಟ್. ಓಕೆ, ಡನ್. So next we will continue. So this is the last part of different types of orbits. So this is called as Lagrange points. Lagrange points. So Lagrange is the name of the scientist alva, who discovered these points by his own imagination. That means, so if you take, this is Earth alva, so this is Earth. So here we have Earth, here we have sun. Clear? So generally, while an object is rotating, so it will create some gravitational pull, any large object. Clear alva? So why the moon is revolving around the Earth? Because Earth is a larger object. Moon is a smaller object when compared to Earth. So that is why Earth is pulling moon towards the Earth. So that is why moon is revolving around the Earth. Idha artha aitalva? Same thing. In general, any larger object, so revolving in the space, will attract the smaller objects. That is the concept. Any larger object for that matter, either it is sun or it is Earth, moon, Mars, anything for that matter. If it is large, while revolving, because of centrifugal force and centripetal force, ಎರಡನ್ನು explain ಮಾಡ್ತೀನಿ next. So because of that, it will create gravitational pull. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, gravitational pull ಅಂತ ಹೇಳಿದ್ರೆ almost like this. So gravitational pull ಇರುತ್ತಾ towards the Earth. From the Earth, it will pull towards this side, and sun into gravitational pull ಏನಿರುತ್ತೆ, so it will pull the Earth towards sun. If you place So this is the spot where both the gravitational pull will be balanced. ಆಯ್ತಾ? So Earth's gravitational pull ಈ ಕಡೆಯಿಂದ ಎಳೆಯುತ್ತೆ. So if you place the satellite here, satellite will come to Earth. ಅಲ್ವಾ? ಬಂದ್ಬಿಟ್ಟು ಅರ್ತ್ ಮೇಲೆ ಬಿದ್ದು ಹೋಗುತ್ತೆ. So if it is just far away from this point, so it will be attracted by sun. This is the actual point where if you place the satellite, it will not attract towards sun, nor it will be attracted towards the earth. This is called as Lagrange point. So in the entire universe, we have 5 different kinds of Lagrange point where we can use satellites for observation. Clear? So this is the point where we are launching Aditya-L1 mission anta kelidira. Have you heard about the satellite? Aditya satellite launch madadralva. It is called as Aditya-L1 mission. It is not just Aditya mission. So they have called it as L1, not A1, B1, C1. They have called it as L1 because that satellite has been launched to this L1 point. So next in ಮೇಲೆ ನಿಮಗೆ ಯಾವುದೇ series satellite launch ಮಾಡಿದಾಗ if they have mentioned it as L1 means where they are going to place the satellite in L1 point. So that is the meaning. So in rest of your life ನೀವು ಸಾಯೋವರೆಗೂ ನ್ಯೂಸ್ ಪೇಪರ್ ಅಲ್ಲಿ L1 ಅಂತ ಬಂದ್ರೆ with respect to prefix ಅಥವಾ suffix ನಲ್ಲಿ ಯಾವುದೇ satellite ನ ಜೊತೆಗೆ that means they are launching it to the L1. So here the satellite will start to rotate along with the gravitational pull of earth. So earth attract ಮಾಡ್ತಾ ಇರುತ್ತೆ and sun is also attracting. So because of these attraction, it can spend very least amount of fuel. Otherwise, if it is placed here to escape from earth's gravity, it needs to spend a huge amount of fuel. Fuel ಜಾಸ್ತಿ ಖರ್ಚು ಮಾಡಬೇಕು. ಇಲ್ಲಿತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ there is no need of fuel. Thrusters ಗಳಂತ ಇರುತ್ತೆ. ಎಲ್ಲಿ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಆಗುತ್ತೋ ಅದನ್ನ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಮಾಡೋದಕ್ಕೆ we have thrusters. Satellites ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ ಹೇಳ್ತೀನಿ. Just by using thrusters, it can balance the speed. ಸ್ವಲ್ಪ ಹಿಂದೆ ಅಥವಾ ಸ್ವಲ್ಪ ಮುಂದೆ ಆದ್ರೆ it needs to spend lot of propellants to escape from the gravity of either sun or earth. So this is the concept. So ಇಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? So earth is attracting this side. So it will start to rotate because of that attraction. Earth na ಜೊತೆಗೇನೆ it will start to move around the sun. So is there necessity to spend so much of fuel? Gravitational pull balance ಆಗಿರೋದ್ರಿಂದ you no need to escape, forcefully escape from the gravitation. Gravitation ಇಂದ ನೀವೇ ಫೋರ್ಸ್ ಆಗಿ ಎಸ್ಕೇಪ್ ಆಗೋ ಅವಶ್ಯಕತೆ ಇರಲ್ಲ because at that point gravitation is completely neutral. It is completely balanced. Clear? The same kind of thing we have L1, L2, L3, L4 and L5. Okay, so we are placing satellites at L1 for what is Aditya-L1. Satellite name ಕೇಳಿದಿರಲ್ವಾ? Aditya-L1 mission ಅಂತ ಕೇಳಿದಿರಾ? Heard? So why we have named it as Aditya? What is the meaning of Aditya? Aditya means sun. Alva? So for the observation of sun, we are placing Aditya-L1 mission at L1 Lagrange point. ಅಂದ್ರೆ so solar waves, solar wind ಏನ್ ಬರುತ್ತೆ, solar activity will be first noticed by this satellite before it reaches earth. ಅಲ್ವಾ? So ಸೂರ್ಯನ ಕಿರಣ ಭೂಮಿಗೆ ಬರೋದಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕು? How much time it will take the sun rays to reach the earth? 8.5 seconds, something like that. So before 8.5 seconds itself, this satellite will notice the changes. So since it will notice the changes, we can protect the earth according to the changes. Clear? So ಹಾಗಾಗಿ ಸೂರ್ಯನ ಅಬ್ಸರ್ವ್ ಮಾಡೋದಕ್ಕೆ ಇರುವಂತ ಪಾಯಿಂಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವುದು? To observe the sun, that is nothing but L1 point. And L1 point is most important. ನಾನು ಅದಕ್ಕೋಸ್ಕರನೇ ಡೀಟೇಲ್ ಆಗಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಮಿಕ್ಕಿದೆಲ್ಲ ಸೊ ಈಸಿಯಾಗಿ ಹೊರಟೋಗುತ್ತೆ. ಆಯ್ತಾ? ಸೊ ವಾಟ್ ಈಸ್ ದ ಇಂಟೆನ್ಷನ್ ಆಫ್ L1 ಪಾಯಿಂಟ್ ಅಂಡ್ ವಾಟ್ ಈಸ್ L1? L1 ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? Gravitational pull will be balanced at certain point, that is called as L1 point, where you can place the satellites by using very least amount of fuel. You can revolve around the sun for the observation of changes. So this is one. So Aditya L1 satellites ಗಳನ್ನ ಇಲ್ಲಿಗೆ launch ಮಾಡ್ತೀವಿ. Then L2. So you are going into a thick forest at the night time. Night time ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದೀರಾ? You are getting into a thick forest, so there is no light. ಅಲ್ವಾ? Somehow you are making some observations. So sudden ಆಗಿ ನಿಮ್ ಕಣ್ಣಿಗೆ ಟಾರ್ಚ್ ಬಿಟ್ರೆ, heavy beam of light so will be penetrated into your eyes. Is it possible to make observations? So that is the case when the satellite is near to the sun. ಸೂರ್ಯನಿಗೆ ಹತ್ರವಾಗಿದ್ರೆ, so because of that so much of glare, ಸೂರ್ಯನ ಕಿರಣಗಳೇನಿದೆಯೋ ಅದರಿಂದ it is difficult to make some observations about the whole universe. So that is why we are placing satellites to the shadow region of the earth. So this is the shadow region of the earth. Clear? So illige place madodrinda, so you can have, so sun will not have, I mean there is no disturbance of sun glare, and from this point you can have a very larger picture about the whole universe. Rest of the universe ಬಗ್ಗೆ ಏನು ಮಾಡಬಹುದು, you can make so many observations. So that is why we are placing satellites at the L2 point. What is the intention? To avoid the glare of sun. Alwa? So intensity of light to cut off the intensity of light that is coming from the sun. That is first point. And second most important point is to make a very large view of the rest of the universe. ಅಲ್ವಾ? ಬೇರೆ ಸ್ಯಾಟಲೈಟ್ ಗಳಾಗ್ಲಿ, ಬೇರೆ ನಿಮಗೆ ಮಾರ್ಸ್ ಆಗಿರ್ಬೋದು, ಬೇರೆ ಪ್ಲಾನೆಟ್ಸ್ ಗಳನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡೋದಕ್ಕೆ ದಿಸ್ ವಿಲ್ ಬಿ ಹೆಲ್ಪ್. That is why we are placing satellites at L2. Clear? So these 2 points are this one, what is that? Hubble's telescope. Hubble telescope ಏನಿದೆ ಅಲ್ವಾ? So Hubble telescopes will be placed here. I mean already they have been placed here. So Hubble telescope ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಯೂನಿವರ್ಸ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡೋದಕ್ಕೆ. So it has already been placed in L2 Lagrange point. And the rest of the planets, asteroids, so comets, ಬೇರೆ ಬೇರೆ planets, ಬೇರೆ ಬೇರೆ changes ಏನಾಗ್ತಾ ಇದೆಯೋ, so everything will be noticed from the shadow region of the earth. ಆಯ್ತಾ? So these 2 points are extensively used at present. So rest of the thing, L3 is also an imaginary point. Theoretically it is true, but practically till now we have not used L3 point. Because so if you place the satellite here, so from all these places you can observe the front part of the sun. Correct? Whereas if you place the satellite to L3, you can make observations of backside of the sun. ಸೂರ್ಯನ ಬ್ಯಾಕ್ ಸೈಡ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದಾ, ವಾಟ್ ಆರ್ ದ ಚೇಂಜಸ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿ. ಕ್ಲಿಯರ್? ಬಟ್ ದ ಪ್ರಾಬ್ಲಮ್ ಈಸ್, ಸೊ ದೇ ಆರ್ ಆಲ್ ಕಾನ್ಸೆಂಟ್ರಿಕಲ್ ಇನ್ ನೇಚರ್. ಅರ್ತ್, ದಿ ಸ್ಯಾಟಲೈಟ್ ಅಂಡ್ ಸನ್, ದೇ ಲೈಸ್ ಇನ್ ದ ಸೇಮ್ ಪ್ಲೇನ್. ಕರೆಕ್ಟಾ? ಸೊ ಇಫ್ ಯು ಪ್ಲೇಸ್ ಸ್ಯಾಟಲೈಟ್ ಹಿಯರ್, ಸ್ಯಾಟಲೈಟ್ ಯಾವ್ದ್ರ ಮೂಲಕ ಕಮ್ಯುನಿಕೇಟ್ ಮಾಡುತ್ತೆ? ಥ್ರೂ ರೇಡಿಯೋ ವೇವ್ಸ್. ಇಫ್ ಯು ಪ್ಲೇಸ್ ಎ ಲಾರ್ಜರ್ ಆಬ್ಜೆಕ್ಟ್ ಹಿಯರ್, so how can you communicate these waves? So it will be cut off here. Sun will always distract the radio waves which are passing from L3 point satellite. So that is the reason why we are not placing the satellite here at L3 point. But this is the best place to make observations of changes that is taking place in backside of the sun. Clear? Then we have L4 point and L 5 point. Lagrange 4 and Lagrange 5. So L4 ಮತ್ತೆ L5. So both are of, ಇದೊಂದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, both are of 60 degree. 60 degree and 60 degree. So we have recognized, we are trying to recognize 2 points, L4 and L5. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, this is also very curious, correct ಆಗಿ ಕೇಳ್ಕೊಳ್ಳಿ, that so gravitational pull of earth will be, I mean sun will be here. Sun gravitational pull will be present and earth is revolving around itself. So while it is revolving around the sun, earth is revolving around itself. Bhumi adara sutta taanu sutta idya. While it is, I mean revolving, it will create, it will attract the objects. So while revolving, it will reach this point. That means idra waves ಯಾವ ರೀತಿ ಸುತ್ತಾ ಇರುತ್ತೆ, ಈ ರೀತಿ ಸುತ್ತಾ ಇರುತ್ತೆ. So it will create a triangle shape, attraction from this side, attraction from this side. So if you place the satellite, sorry, here, triangle shape irutte. If you place the satellite here, so satellite will be stagnant. ನೀವು ಹೊಳೆಯಲ್ಲಿ ಸುಳಿ ನೋಡಿದಿರಾ? So ಸುತ್ತ ಇರುವಂತ things ಏನಿದೆಯೋ, so they will start to revolve. But if you place an object, so ಒಂದು ಬೆಂಡ್ ನ ತೆಗೆದು ನೀವು ಸೆಂಟರ್ ಪಾಯಿಂಟ್ ಗೆ ಇಟ್ಟರೆ ನೀವು, so it will be stagnant. And even sometimes it will not revolve also. ಹಾಗೆ stagnant ಆಗಿ ನಿಂತ್ಕೊಳ್ಳುತ್ತೆ. So these are the points, they behave like that, L4 and L5. That means with the least consumption of fuel, here also L4 ಮತ್ತು L5 ನಲ್ಲಿ you can start observing. Can you say something? ಏನಾದ್ರು ಹೇಳ್ಬೋದಾ ಇದ್ರ ಬಗ್ಗೆ, ಈ ಪಾಯಿಂಟ್ ಬಗ್ಗೆ? Why we have to choose L4 and L5? Any assumption? From this point, at a time, you can make observations of both sun as well as earth. Is it not possible? So satellite ನಲ್ಲಿ place ಮಾಡಿದ್ರೆ, so it can make observation of L5 only. So it can observe the changes in sun as well as it can make the observation of changes that is taking place in the earth. So that is why we are choosing L4 and L5. L2 most important, L3, L4 and L5 are least important. Concept ಅರ್ಥ ಆಗುತ್ತಾ? ಸಿಗೇನಿಲ್ಲ, just definition ತಗೊಳ್ಳೋದು, ಮುಂದೆ ಹೋಗ್ತಾ ಇರೋದಷ್ಟೇ. So they are, that means L1, L2, L3, L5 are very special points in the universe of the regions of attraction and repulsion. Clear? So then particular definition about each and every points. L1, it is present between earth and sun, where the gravitational pull is neutralized, balanced. So that point is called as L1. Why we are using? For the constant view of sun. So which are the satellites we have? We have launched Aditya-L1 satellite to make constant observation of the changes that are taking place on the sun. Either it may be solar wind agirbodu, fusion reaction that is taking place irbodu. So any changes that is taking place on the sun. So helium reaction ಆಗ್ತಾ ಇರುತ್ತೆ. So everything is noticed. First space based observatory which has launched by India. So next one is L2. So mark it. So ಎರಡನ್ನ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಳ್ಳಿ, that L1 is important and L2 both are very very important, and L1 is like VVIP. L1 is most important. So questions ಬಂದ್ರೆ majority of the questions are from L1. So L2, so first point is it is located behind the earth, or it may be also called as shadow region of the earth. Earth is between L2 and the sun. Okay, so L2 point al haktivi. Earth is present between, so backside is L2, front is sun. It is the strategic place to observe the larger view of universe. Just underline this. So this is the keyword, to make a larger view of universe. ಇಲ್ಲಿ ಬರ್ದಿದೆಯಲ್ಲ? Okay, so good. James Webb telescope ಅಥವಾ Space Telescope has already placed at the location of other points are L3 is on the back side of the sun, or other side of the sun. So till now, as of the date, we have not yet launched any satellites to L3 point. Clear? And NASA Dauru, so they have launched satellites to L3 and L4, where ISRO, so India we have not yet launched any satellites for L4 and L5. So this is your current affairs, present situation, present scenario. So apex means you write it as 60 degree from the earth. So question has been asked in UPSC. So idra mele already, so they have raised the question. UPSC nalli bandide anta helidre, see, there is no difference between UPSC and KPSC. UPSC il bandide andre KPSC il barutte, KPSC il bandide andre maybe we can expect in some other exams. Clear? So done. With reference to AstroSat, see adanandre nanu helta irodu, it is not important to read AstroSat. I'm telling you that this concept is important. In 2016 they have launched AstroSat. Alva, adra ಬಗ್ಗೆ ನಾವು ಓದಬೇಕು ಅಂತಿಲ್ಲ. So that is current affairs in 2016. So if there is any current affairs with respect to these Lagrange points this year, that will be important for your upcoming exams. That is the meaning. Alva? So 2016 with reference to AstroSat, the astronomical observatory launched by India. Which of the following statements is or correct? 2016. So other than USA, just it is an information astane. Other than USA and Russia, India is the only country to have launched a similar observatory into the space. So in 2016, this was a wrong answer, because other than USA and Russia, so we have other countries as well. One is European Union and Japan. So they have also launched astronomical observatory satellites. So hagagi, first option is wrong. I'm telling you that. So if there is any current affairs on this topic, try to focus. Second one is AstroSat is a 2000 kg satellite placed in an orbit at 1650 kilometers. LEO, MEO or GEO? 1650. Almost balance. I mean, it is a point between LEO and MEO. You can consider it as LEO as well. Kilometer above the surface of the earth. So it is not 2000, so it is 1513 kgs and 650 kilometers, not 1600 kilometers. Okay, so it has been launched by using a launch vehicle PSLV. PSLV ಬಗ್ಗೆ detail ಆಗಿ ಹೇಳ್ತೀನಿ, Polar Satellite Launching Vehicle. So we'll be discussing in details when we are discussing about launch vehicles. So these are the exact answers. Option second is also wrong. So both, neither one nor two. Okay, 2016 ಅಲ್ಲಿ question this concept was important. So ivaga if there is any recent launch ಆಗಿರೋದು ಕೂಡ ಹೇಳ್ತೀನಿ, 100th launch, 101 launch, satellite launch ಕೂಡ ಹೇಳ್ತೀನಿ. Those things are important. So ivaga recent ಆಗಿ launch ಆಗಿರೋ satellite ಏನು, what are the features of that satellites, in which part, in which orbit we are launching, so what are the facilities we can borrow from that satellite. So that will be important. Adanna kuda with picture, so we are going to discuss.